So what we're going to do now is talk about applying key operators in the Flux class for the second part of our ex3 case study. And this will demonstrate a bunch of other things that we have mentioned before. We're not going to focus as much on exceptions in this particular example. And it also shows a bunch of mono operators, some of which we've seen before, some of which we haven't. As always, you can get this in my GitHub repository under live lessons in the Flux ex3 folder. So we're back in my IntelliJ project for the second part of case study ex3. Here's what it looks like. In case study part 1, we talked about the exception processing methods. In case study part 2, we're going to talk about these multiplication methods. Other than that, it works the same as it always does. So let's go ahead and open up the flux ex.java file. We'll start with test fraction multiplications 1. This is going to test an asynchronous Flux stream consisting of generate, take, flat map, and collect, and a pool of threads to do reductions and multiplications. Here's what it looks like. We make ourselves a string buffer, as always, and we use the generate method on the Flux, and we're just basically going to use this to make a big random fraction. We've seen this code a million times now, so I won't relook at it, but it basically creates a large, unreduced big fraction. And we're going to stop after we get S max fraction of these things. And if you take a look there, that's 10 of them. So after 10 of these things, we'll stop. For the 10 that we generate, of course, we're going to use flat map. And we're going to use flat map with the flat map concurrency idiom. And to do that, we're going to kind of consolidate it into a method called reduce and multiply fraction, which takes the unreduced fraction, a parallel thread pool, scheduler, and the string buffer. And it'll then go ahead and do this call. You can see what it does. It returns a mono. See, it returns a mono to a big fraction, which will reduce the unreduced fraction that was passed as a parameter. It'll do that in a background thread from the parallel thread pool. It'll log the results, and then it'll go ahead and multiply the big fraction by some constant. And you can see what the constant is over here. It's nothing exciting, just whatever that is. So that's what it's doing. It's returning a mono that does all those computations, and that will then basically return a mono to a list of big fractions. Sorry, it'll return a stream of big fractions, which we then collect into a list by using collect. So now we get a mono to a list of big fractions. And then we go ahead and sort and print that list. So just kind of demonstrating how you can do the flat map concurrency idiom. Very clean, very easy, very nice. Let's now take a look at test fraction multiplications 2. Similar in a lot of ways. We're going to use a different factory method. We're going to use from array here. Whereas up here before we used generate. So before we generated these things and then stopped after 10. Here we're just going to have an array that has 4 big fractions in it. We're going to go ahead and use the flat map concurrency idiom to multiply these things. In this particular case, these are going to start out being reduced big fractions. So we have an array of reduced big fractions. We're now going to multiply them together. We don't have to reduce them, we just multiply them. That's a super easy thing to do. We just multiplies them in a background thread. And then what we're going to do is after we've finished multiplying all these things together, we're going to use the reduce operator to add up or sum all the multiplied values, which we then go ahead and print. And then the third and final example here, we'll use some other stuff. And let's take a look and see what this is going to do. It's going to use the generate method again. It's going to use take again. It's going to use flat map. Oh, I know what I was doing here. This is pretty cool. Now I remember why I did this. So we're going to use flat map to reduce and multiply these big fractions asynchronously. So that's all kind of like what we did before. But now we're going to do something a little different. We're going to use another method called collect multimap. What the heck is collect multimap? Well, what collect multimap is going to do is it's going to collect the results. Remember, we have this stream of big fractions that have been multiplied and reduced coming out of flat map. And what we're going to do is we're going to make a new hash map. And this hash map is going to have the keys be the numerators and the values be a collection of the denominators. So this is just to show off another way to use collect. So collect multi-map. And then we're going to go ahead and print the contents of the map using flat map. So let's go ahead and take a look at the output from this thing. This is pretty funny. This is test fraction multiplications 3. You can see how we end up with the keys being the numerators and then the denominators being this list of big fractions, which I think there's just one of them in this particular case. So anyway, it's a very interesting use of collect multi-map. And the other things are just results of multiplying the stuff together. You can also see something else here, that the test fractions multiplication 2 method finishes before test fraction multiplications 1, even though test fraction multiplications 1 was called first, just showing how parallel processing works, and shorter things take less time, so they finished before the other one did that took longer. Also showing off the features of the async task barrier that will return the completed tasks in the order they complete, not the order they were initiated. So that's the end. Oh, let me just show print map. So here's what print map does. What it basically does is it goes through the map, and for each numerator, it goes ahead. Actually, what it does here, it says for each numerator and denominator pair, we say for each denominator, go through and print things out in the proper order. So again, just showing off some wacky stuff you can do with collect multi-map. All right, that's the end of case study EX2. At this point, you should have everything you need to do in order to complete assignment 4A.